Hello and welcome to this course. This is just a preview of my complete SQL for Data Analysis beginner to advanced course on Udemy. A step-by-step teaching with real-world business example. And in this full Udemy course, you learn SQL basics to write select, where, join. You learn data cleaning and transformation with SQL. And you also learn advanced functions, window functions, CTEs, aggregations, and also in this course, we use real-world business projects and datasets. So by the end of the course, you'll know how to use SQL to answer business questions, analyze data, and make better decisions. This is a skill that every data analyst needs. So enroll in this full course today for just £11.99. with the special coupon link that is in the description of this video. You can also see the review from people that have already enrolled for the course, and this should tell you how resourceful the course is. Now, please don't forget to subscribe to my channel for more data analytics tutorial on SQL, Power BI, Python, and AI. Enjoy the course and put your review in the comment section, and also like so that others can see the course. Thank you. Hello everyone, and welcome to SQL for Data Analysis. My name is Yusuf, and I'm a senior data analyst working for one of the health and social care trusts in the UK. I've spent much of my career digging into data to uncover insight and drive better decision making. So I'm excited to share with you how SQL can become an indispensable tool in your own data analysis journey. SQL is incredibly versatile, although it is often associated with software development, and it also plays a huge role in analyzing and understanding data. In this course, our main focus will be on the techniques and queries most valuable for data analysis. And the best part of this course is you don't need to be an analyst or even have any prior technical experience to benefit from these lessons. This course is designed to be accessible to professionals across marketing, operations, finance, healthcare, and more. Today's organizations capture huge amounts of data, and employees in all departments are increasingly expected to make data-driven decisions. While there are many tools out there, any seasoned data analyst or data scientist will tell you most of their work happens in SQL. So by the end of this series, you will have a solid foundation to confidently query database, explore datasets, and extract meaningful insight. Let's dive in and unlock the power of SQL together. Before we go deeper in our course, we need to install the software we'll be using for our course, which is Microsoft SQL Server. To do that, let's go to our browser and just type in the search bar Microsoft SQL Server. So let's do Microsoft SQL Server download, and then you click on this second link. So if you click on you have to be careful of the link you are clicking from. We are trying to download from Microsoft website, not from any third-party website. So click on this one that says SQL Server downloads. And once we are on this site, we need to come down a bit for what we want to download. Don't click on any of the link at the top here. Just scroll down and we'll have our SQL Server we want to download. And there are actually two versions of SQL Server. There's one for developer and there's another one for Express. So for this course, any one of the two will actually work for the course, but it's better to download the developer option because it has more features which the SQL Server Express does not have, and again it's good for development. So let's click on download. So once our file is downloaded, then let's click on open here. So another option we have to pick here is to pick the custom option, and then it will definitely ask us if we want to browse the location or we want to save it to, or if we're okay with this part. I'm okay with the part, then I'll click on install. So once we are on this dialog box, so By the extreme left hand side, we can see different options, which is planning, installation, maintenance, and the rest. So we want to do installation right now. So we click on installation. And after that, it will ask us what would we like to install. So we want to install a new SQL Server, and we click on new SQL Server. So once we are here, since we have already specified developer, we don't need to enter a product key. So we click on next. And after that, we accept the license term. Click on next. So we should get all this result, and for this window firewall, sometimes you get a warning, but just ignore it, everything is fine. And then we click on next. So this is where we need to pay attention. Now what we want to download is a new SQL Server instance, and the instance will have some features we would like to make available in our SQL Server. So the first thing we would like to make available is the database engine services, and there are other options here which, if you would like SQL Server replication and also machine learning services that will allow you to perform machine learning activities directly in your database, and also full text and semantic extraction. So this is good if you would like to do some regex like regular expression in your data. So for now, we just click on this database instance, and let's click on this full text and semantic. So for the rest, we don't need to do any other thing again. So we just click on next. So after that, we get to this page which will ask us to do some configuration. So this is instance configuration, and then it has a default instances that will just give a default name. So what I usually like to do is just change the instance name, and let's say I'm using my name, let's say Yusuf 2025. And once I click on the instance ID at this page here, you see what happened. You see changes to the instance name that I've given at the top. So, and then you can see the SQL Server directory has also changed, having the instance name that I just created at the end. So we'll click on next. So after that, we'll get to see the services that we have selected during our feature selections when we're doing the installation. You can see that we have our SQL Server agent, which is selected by default, and also we have SQL Server database engine. We selected that. The SQL Server full text filter, we selected that. SQL Server browser, it's there by default. So make sure you tick this box to grant platform volume maintenance tax privilege to SQL Server database engine services. It's important. Then the next thing is do next. So this is an important area we need to pay attention to. So this place now is asking us the kind of authentication mode we would like to use, and authentication mode is how we'll be able to sign into SQL Server and have access to our database. And also, if we would like to connect our database to another kind of service, like maybe Power BI or to a different application, so we would need to provide authentication, which is a login details. So right now, it's asking us if we would like to use Windows authentication mode. So this has been selected for us by default, but it's a good practice to select mixed mode, which is SQL Server authentication and window authentication. After that, you see that username is usually system admin SA, which we can change. So what would be okay for us to do now is to enter the password that will be connected to the account. So enter your password. So ensure that the password matches the one at the top. If not, you get an error. And after that, again, what you do is click on add current user, which is very important. Once you click that, the current user comes up into this box. So that's a good one. And then we click on next. This is just a summary of what we have selected and the action we have performed so far. So we'll click on install. So our installation is complete, and then we click on close. So that is the SQL Server instance we have installed. So we would need to install another software, which is the management tools. So that will help us to be able to link the instances we have installed to a front end, like a front facing website, for us to be able to interact with the database. So after that, we'll click on install SQL Server management tools. And once we click on that, it takes us to this website where we'll download the management tool. So scroll down a bit and click on download SQL Server Management Studio. So once that is done, we open it up. And then we'll click on install. The location is fine for me, so we'll click on install. So once our installation is complete, then we'll close this, and then we'll go to our application menu, and we'll see it's already here, SQL Server Management Studio. And also if we go here and scroll down a bit, so you'll see the SQL Server 2022. That is the instance where you can also come back to this installation center to maybe activate a service you would like to use. Well, for this course, we would be able to interact with our instance, the server we just created, by using this SQL Server Management Studio 20. When you open it, so once we load this, we can see the instances that I have, which is Yusuf 2025. So if you come down here, the connection security, you can choose optional and make sure to always tick this trust server certificate. And if you do that and do connect, so we are connected to our SQL server and we can see the database. We have nothing else on this right now, and this button is for connection and this is to disconnect. So let's disconnect and let's try another means of connecting. So once you have disconnected, let's click on this connect button and let's try using SQL Server authentication. So using SQL Server authentication, you remember I told us the username will always be SA, which stands for System Administrator. So let's put SA, and the password will be the password you supplied while you were installing this. So let's do the password now. And you can click on remember password. And also for the connection security, the encryption should be optional depending on your choice, and trust server certificate and click on connect. So whichever method we are using to connect will get us to this place, but it's just important to know which one to use. So when we are connecting our database, our SQL server, to a third-party application like maybe Power BI, then we would, in an ideal production environment, we would use the SQL server authentication, which will supply the username and the password. So that is the installation of SQL Server. For this course, we would have an hypothetical case study. So imagine yourself as a data analyst working for a company called Backwoods Paper. In this company, we'll take a real life scenario or business case study. So imagine yourself as Mike, a data analyst that has been employed by Backwoods Paper in the USA. This is the hypothetical company we'll be using in this course. Mike, as a data analyst, has been employed to help the company leverage their data for data-driven decision making. So different departments of the company, such as the marketing, the finance, and the operation, will come to Mike to ask different questions relating to the data the company has been storing. And Mike is known as an analyst, which is skilled in SQL. So let's take a look at some different questions or email Mike will be getting as a data analyst working for Backwood that needs to use SQL to answer these questions. For example, we have Tim, which is the finance manager, can come to Mike or send an email to Mike and say, Mike, what is the total revenue by paper type for the last quarter, and how many orders are missing one or more paper types, and how do their average value compare to complete orders, and also what is the average unit price for standard paper, and are there any orders that significantly deviate from this average? So these are the questions that can come from teams, and there are many more in the future that we'll be tackling in this course. So Mike is expected to answer these questions by querying the database of the company and give an answer back to the finance manager. So somebody else from supply chain, let's say for example the name is Kate, is supply chain manager, and would send an email to Mike and say, I would like to avoid overstocking a product that is not selling well in different regions. So this manager is trying to see how they can maximize profit and also space, being the supply manager. So they would like to know the top selling products in our region and the least selling products in our region. These are the kind of questions that can come from supply chain manager. So this is just to avoid overstocking a product that is not selling and losing profit due to that kind of action. So another person from, let's say, sales can reach out to Mike and say, oh, Mike, we have identified key accounts and I would like to see how they are performing. So the account ID are 101 and 1021. So this kind of questions could arise from the fact that Alex, which is a sales manager, is trying to ensure they keep their most precious customers and ensure that they don't churn or go to a different supplier or their other competitors. So by understanding the performance of these accounts, they can then look at maybe what kind of incentive can they give to ensure their retention. Do you understand now? So these are the kind of questions Mike, as a data analyst, would have to answer for Backwoods Paper managers, like the sales managers, the supply chain and finance manager. Even people from marketing can reach out to Mike if they have data stored for marketing. You understand now? So for Mike to be able to answer this effectively, Mike needs to understand the way Backwoods Paper stored their data and how these data are related to one another. So we would look at that in the next video. The first thing a data analyst needs to understand is the database and the data stored in it. The company that has employed us as a data analyst is Backwoods Paper, and this is their database, which they have stored in it different tables. We have the account tables, which stores the account ID, the name of the account. The account can be regarded as the clientele or the customers they have, and the website of the customers, the latitude and longitude, the primary point of contact, and the sales rep associated with each customers. And we have the orders table, which has the unique order ID, the account ID, the occurred at. This is a timestamp that shows the time and date when an order occurs. So we also have the paper type and the quantity of the paper type and the amount sold. So our company deals with paper. We have sales rep, their name, the ID and the region. We have the region table consisting of the region ID and the name of the region, which are the 4 regions in the United States. We have the web events table, which also have the unique ID, the account ID, occurred at, and the channel. So this one stores the web activities. This allows us to track where the orders are coming from. The company gets their clients through advertising on different platforms like Facebook, X, Instagram, and Google. So something like that. So when an order comes in through the web activities or through the web events, then we'll know which channel the orders are coming from. Are they coming from the advertising platform like Facebook, Google, and X, or they are coming directly, or somebody just log into the website directly without coming through an advertising channel. So the whole point is that Backwoods Paper, they have 50 sales rep across 4 regions, and their clients are Fortune 100 companies across different industries like beverages, entertainment, tech, and fashion industries, just name it. So as a data analyst, you need to understand this so that we'll be able to answer complex questions like which product is underperforming or which marketing channel should receive a large investment. So let's get started and uncover the insight hidden in this data. So in the next video, we'll be looking at how to create a database and then load data into the database for us to be able to then query the data and derive meaningful insight or be able to make data-driven decisions. In this video, we are going to create our database, and after that, we will then create the table that will live in the database. For us to create the database, we right-click on the database and click on New Database. So once we click on that, we will have this dialog box that will ask us for database name. So we would then write the name of our database. So the company we are working for is Backwoods Paper. So we can write Backwoods Papers DB. So Backwoods Paper DB. So the writing of the name, the convention for writing the name is actually your choice. You can do snake casing or you can write everything in lowercase, but for now I would like to write it this way. So Backwoods Paper DB. So the next thing I'll do is click OK. Once I click OK, it then adds to the list of database that I have in my system already. So right now this is Backwoods Paper DB, and right now if you click on the icon beside it, this plus icon, we then see the properties of the database. So right now we see the database diagram, the tables, views, and other stuff that are part of the database. So if I click on the table side, the tables will be empty because I don't have any tables in the database right now. Our database would hold 5 tables, and there are the account tables which would have the account ID, the account's name, website, longitude and latitude, the primary point of contact, and sales rep's ID. So we have the orders table, we have the sales rep, we have the region, and we have the web event. So those are the 5 tables that will be living in our database. Once we have created our database, the next thing is to create the tables that would live in it. And to create table, we use create table statements. So let's take a look at how the statements work. So the create table statement is a statement or the command we use in SQL to create table. And to create a table, you need to provide its name and outline each column along with the appropriate data type for each of them. So the syntax is that you write the create table command or statement, then followed by the table name. You open a bracket. Inside the bracket, you then put the column name. So for example, we have column 1, then followed by the data type of the column. So the data type of column 1 and the column 1 constraints. The column constraints are used to define how each column inputs data or how each column relates to another data or the role of a particular column in the table. So we can also have column 2, the data type of column 2, the column 2 constraint, and so on to column n, the data type of column n constraint, and also at the end we then have the table constraint we close the bracket and put semicolon. So this is the syntax for creating a table in SQL. The next thing is that we'll look at the data type we have in SQL Server. So data type in SQL Server is what makes it unique and more robust compared to just using a traditional spreadsheet. So let's take a look at the data type. So the common data type we have are these. So the first one we'll discuss is the char. We call it char, and it's a fixed length type. And for example, if you are using it in creating a table, the column you are creating, then you want to give it a character, and the number of character you specify is 10. So this is a fixed data type. So it takes in 10 characters, and if you don't put in up to 10 characters into that column, it fills the remaining space with space. It fills them with empty space. So it is important you know why you are using character. And the other one, the second one we have here is varchar, which is an extension of the first one. So this is called a variable length type. It stores only characters you need and up to the maximum you specify. So for example, if you specify a column to have data type of varchar and you put in the bracket 50, so that means it will contain 50 variable characters, but it can take less than that, and it won't be filled with empty spaces. Do you understand now? So that's the difference. So for example, if you want to use char, you can use it to, store something like country code, which is something like maybe USA, UK, something like that are just fixed characters. And for variable chars, then we can use something like this to store names of places, name of people, and stuff like that. So the text data type, it is for storing large amount of text, like paragraph. And we have other one, which is the int, which is also known as integer. It stores a whole number type for storing integer. It ranges from -2 billion to +2 billion. So we also have another type called decimal type, and this is used to store the exact decimal. And the P is the precision, the total digits before the decimal, and S is the scale, so which is the number of digits you want to have after the decimal. So for example, this can be used for storing money or for measurement. So we also have another data type called the bit, which is a simple type of Boolean value. It stores only 0 and 1. So we can use this to store something like false or true. Do you understand now? Like if you're storing if something is part of a particular entity, so 1 will means true, it's part of that entity. 0 will means false, it's not part of that entity. We also have the date type, which is used for just storing the date, the year, the month, and the day. So it stores the date without any time information. So we also have the time data type, which stores only time of day, which is the hour, minutes, seconds, and even fraction of seconds without the date. So we also have the date time data type, which is a combination of date and time into one type. This allows us to record when an event occurred. So these are the data types. These are the common data types we can meet in the creation of a database. And while interacting with database, these are the kind of data, the common data type we can meet. So it's important we understand them. So understanding the data type will allow us to know what kind of operation we can perform on the data type. So we know if it is an integer, then we can perform aggregation like sum, average, division, and stuff like that. So if it is character, then we know we can do text formatting on it. So it is important we understand the data type for us to be able to manipulate the data. So let's move to the constraints we can also encounter when creating a table. So the constraints we can encounter when creating a table, the first one is not null, which guarantees that a column must not contain null value. So when we are creating a table, different columns there serve different purpose. So some columns must not be empty for us to be able to actually track the records we are entering into the data type. So for example, columns that are recording the ID of a particular table, So those kind of columns cannot contain null values. Null values means that the columns cannot be empty. Do you understand now? So we have default constraint. So this will assign a default value to a column if there's no value provided. So sometimes when we are entering data into a particular column, if no data is entered into the column, then we can specify a default value that will be assigned into that column. The unique constraint ensures that every value in a column is distinct. So this is used when we want to show that a particular column contains distinct values. That is, the values are different from each other. So the other constraint is check, which allows us to verify the values that are coming into a column meet a specific condition. And we have the other one called primary key, which serves to uniquely identify each rows within a table. So every records in a table must have a unique value that's identifying the record. And we have foreign keys. The foreign key is used to maintain referential integrity of the data. So we know this is a relational database and the tables are related to one another. So what shows a particular table is related to another table is the referential integrity, which we call the foreign key. So the foreign key shows which two or more tables are related to one another. So we would have to discuss more on these two constraints, which are the primary key and the foreign key. Primary key is essential for uniquely distinguishing each entry within a table. So every record or every row within a table must have a unique identity. That is how we are going to be able to track each record in a table. And this primary key, it comprises of one or several columns in a table. So primary key sometimes can be more than one particular column. So if there are two columns serving as a primary key, we then call these two columns as a composite key. So we call them a composite key because there are two columns serving as a primary key. A foreign key, on the other hand, refers to one or more columns that point to another column. So sometimes it typically points to the primary key in a different table. So the role of the foreign key is to maintain the referential integrity of the data. So let's take an example and see how it looks like. So for example, we have a customer table and we have the other table. So the customer table alone stores the customer ID. So we can see that the customer ID is the primary key here because every customer must have a unique identification for us to be able to track them. So, and to ensure that they are different from each other. So after that, we have the last name of the customer and we have the first name of the customer. So on the other table, we have the order ID, which is also the primary key. So each order is unique. And after that, we have the order date, the date the orders are placed. Then we have the amount of the order. And then we have the customer ID. So the reason why we are having customer ID here is that the customer table and the order table are related. And what in the way they are related is through the customer ID, because we see that customers can place order. And for us to be able to see what order a customer places, we then have to link them together. And by linking them together, we do that using the foreign key. So the foreign key will then tell us which customer have placed a particular order. And a customer can place more than one order. Do you understand now? So by having foreign key, we'll be able to see this kind of information. So in the next video, we would see how we can create table in our database and then how to move data into our database. So we'll be using two methods. The first method is importing a data through a CSV file, and the second method is using the insert statement, which is another command in SQL Server that allows us to insert data into a table by scripting it. See you there. After creating our database, we are then going to create the tables that will live in our database. In this video, we'll create the tables that will live in our database, and then import data into them. So there are two ways we are going to import the data. The first way is using a CSV or a flat file, and the second way is using the insert into statement. So let's create the tables that will live in our database, and these tables are related to one another. So we're just going to create them, and we won't go into the details of how the relations come about because it's beyond the scope of this course. The relation of tables are being done by database architect and database designer. So let's get started by starting with the first table, which is the region table. So if we could remember our syntax of create table, that is what we would put into use right now. So to do that, let's right click on our database. The database is Backwoods PaperDB. Right click on it and click on new query. So once we do that, at the top here, you should ensure that you have Backwoods PaperDB selected. If not, you would be creating table into a different database. So always ensure that once you try to write query into the Backwoods PaperDB, it is also showing at the top here. So let's create the region table. The region table contains two columns. And the first column is the ID, which will also be the primary key, and also the name of the region. So we'll start by saying create table, followed by the table name, which is region, and open bracket, click enter, and then say, do a simple tab, and let's say ID. The data type is going to be int, and the constraint on this is not null, so it cannot contain null value, comma, enter key, the name, and this one will be varchar, and the maximum variables we want to have is 25, and it's also not null, cannot contain null value, and do comma. So the next constraint we are going to put now is to specify our primary key, and we write constraint, the constraint name, which will say region P key, and then write primary key, which is a SQL command, and now we are going to put into brackets which column is going to be our primary key. So we already know it is the ID. We just put into bracket ID as our primary key, and then enter, and this time around we'll close the bracket. So once we close the bracket, we'll put a semicolon and then enter again and say go. So it is important you do this sometimes to separate your statement. This is a single statement or SQL code from another code you would like to write. So this code now would create a region table with ID column and name column, and ensure that our primary key is the ID. So we can create execute, or we can select everything and click on execute. So it's a good practice to select this and click on execute. So once that is done, a message dialog box will come up at the bottom and show the result of the command we have executed. If it failed, we will see the messages. So since it's successful, we'll see commands completed successfully, and then we need to refresh our database. Once we refresh it, expand the table, then we should see our region table. So now we can see our region table. So right now it is empty, so nothing is inside it. So let's write create for the rest of the other table. I'm just going to create two more tables, and we would import data into them. We are going to create 5 tables. So we are going to create 3 tables first and import data into them using the CSV flat file method. So after that, we'll create the remaining 2 tables and then import data into them using the insert value. So let's create the remaining 3 tables. So I can equally clear all this and say create table again, And this time around, the table I would like to create is the sales rep. So sales rep. And it is important that you use underscore to replace space here. So anything you are creating, any table or columns you are creating should not contain space in SQL Server. So if you would like to use space, then you would have them inside square bracket. Like instead of doing sales rep and space, you just do sales rep. And then, so this is the allowed syntax, but if you don't want to use the space, you can just use underscore. So I would like to use underscore instead of using space. So sales rep. And another reason, another place where you can use the underscore is to separate the column you are creating or the object you are creating in SQL Server separate from the keywords. There are some keywords in SQL Server. For example, if you want to name a particular something, maybe table. Table is already a keyword in SQL Server. So it would be good if you wrap it in a square bracket to distinguish it from the main keyword in SQL Server. So create table, sales rep, open bracket, press enter. So this table is going to contain 3 columns: the ID, which is integer data type and not null, comma, name, which is varchar and contains 25 characters and not null, so we also have the region ID. So reason why we're having region ID is that this sales rep is connected or related to the region table. So we'll say region ID, and this is going to be a foreign key in this sales rep table, not null. So the next thing is to specify our primary key and the foreign key. So reason in the first table we only specify primary key because it doesn't contain a foreign key. So this sales rep table now contains a foreign key. So we have to specify the foreign key and the primary key. So let's do the primary key constraint and we'll name it sales reps P key. And then we'll write this SQL keyword primary key and then specify the primary key, which is the ID. So 2 comma, another constraint, this will now be specifying the foreign key. So the naming convention is that for the foreign key, just put FK at the start of the name and then just put the column name following it, region ID, and also the keyword, the keyword here is going to be foreign key, and then we are going to specify the column that will serve as that, which is the region ID. And now we are going to connect this foreign key that we have created to the region table. So to do that, we then write, so references, we'll say DBO region table, because the region table is dbo.region. So, and open the bracket and say the column it will be connecting with that we are going to reference is also the ID column, which is the primary key of the region table. So once we are done with that, we then do on delete, no action, on update, no action, and we are done with this. So I think we are all good. So we can then say go for this. So let's let's highlight these and execute. So we have the sales rep table created, and if we refresh our database, we then have it. So we have the sales rep. So we'll create one more table and show us how to import data into this. So let's delete all this. And then we'll create the accounts table. So create, I won't be explaining any of this just to save time. Create table. So we have these three tables now. We have the account, region, and sales rep. So for us to get data into this table, the first method we want to explore is the CSV method. So the CSV method, we'll right click on our database, and then we'll click on task. And inside the task, we'll click on import data. So once we click on that, a dialog box will come up. So we'll click on next, and it will try to ask us for the data source. Click on the drop down arrow here and say flat file source. So once we click on that, this will load, and we'll then be able to browse the file we want to import the data from. So once you are in the folder where you have your CSV file, so right click on this, you can do all file or CSV file. So the first one we would like to import is the region table. So click on this region, open it. And once you open it, you can then look into the column and see if there's anything that's different. So just like previewing the data before you import it, and also you can change the data type and probably change the name, change the column delimiter and stuff like that. So for now, we'll just click on this and change this. Since our data type is not strange, the ID is not meant to be strange. So based on the table we created the ID to be integer. So we look for integer data type here. So let's do this single byte signed integer. And if it is the name is strange, so we are okay with that. So we just click on next. And then it will ask us for destination, to choose a destination. So when you choose a destination, click on this drop down arrow and then scroll down. You see this Microsoft OLEDB provider for SQL Server. Click on it, and after that, you should see your server name. Once you see your server name, the authentication mode we want to use, you can continue with the use window authentication. That's fine, and ensure the database is backwoods paper DB, just the database you are trying to import the data into. So once you click on next, so we can do edit mapping to see where we are going to. So right now the source is having this and the destination is having this, so I think we are fine. We click OK, and then we click on next. So once you click on next, it will try to do the conversion and everything here. If there's an error, you get to know if the source data type is not matching with the destination data type, so you get to understand from here. So click on next and click on next again. So you click on finish, then it will run the data importation. So once it is done, it will let you know, and you can click on close. So once that is done, you right click your database and you refresh again, and this time around we check the table. And for us to preview the data in our table, we right click on the table and do select top 1000 rows. If you do that, it will automatically show us the first 1000 rows in our data. So right now the region data have this amount of data, and these are the values we can see. So I'll just do the import for the rest of the tables, and you can also follow along. If there's an error, put your question in the comment section and I would look into that. So for the rest, we'll do the same process. Right click on this. So now we have import all the data into the tables, and we can quickly preview the table by doing right click, select top 1000 rows. And for the sales rep table, you should have 50 rows. You should have 50 rows, and these are the data in the sales rep. So if you do the accounts table, preview the accounts table, you should have this, and you should have 351 rows. So that is how to import data using the CSV file method or flat file method. The next method we want to look into is using the insert values. So first, let's see the syntax of the insert value. The insert into statement is used to add new records to a table in a database, and the syntax is that we write the keyword or the SQL command insert into, followed by the table name, and in bracket we have the column name, the column 1, column 2 till the last column, then followed by another SQL syntax or SQL keyword, which is values. Then in the bracket we then have for column 1 we then have the value of column 1, value of column 2, and so on and so forth. So we can have as many of these statements as possible. So this will just only insert a single record or a single row of in our table. So if we have multiple rows we want to add into our table or multiple records, we have to use multiple value keywords to also specify all the records. So let's take a look at that. So we have two more tables we would like to create, which is the order table and the web event. So we'll be using the insert values to add data into this table. So to do that, I'm just going to copy the already written script. It's a SQL script. So I'm just going to copy them and run them. So we'll do new query, and we always ensure that we are using the backwards paper DB, and we'll paste this. So let's scroll up. So this is the syntax that will create the table. The columns are the ID, account ID, and the rest. And after that, you can see the insert statement. This first line is going to insert into the other tables the values, and also this one will go into the other ID, and this will go into the account ID. This date time will go into the occurred at, and followed by the rest of them. So you will notice that there's a slight difference between this and the syntax I showed us. The reason why it's different is that if your column does not contain any null, you can skip in the front of this table, you can skip specifying the column for the table if you are sure that the values you'll be entering into the tables there's no null. So SQL Server will just understand that this one goes into the first column, and the next one to the next column, and the next value to the next column, and so on and so forth. So we can run all this. We don't need to highlight, or we can also highlight depending on the one you like, and just click on execute. So we wait for the result window. This is actually quite large. So once this is done, we refresh our database and then expand the table. So right now we can see the orders table, and if you preview it, select top 1000. So you can see the orders table right now. So the values we have in the orders table are more than 1000. So we are just seeing the first 1000 row. So after that, let's do the same thing for the web event. So we'll copy the web event script. Let's paste and execute this also. So once that is done, refresh the database and then expand the tables. So we should see the web event table. This is web event, and if we do select top 1000 row, so we also see the web event. So we can see the ID, the account ID, the time the transaction occur, the channel, is it through direct, or there are other different channels, just like we explained initially that, people come through advertisement, maybe from Facebook, Google, or Twitter. So now we have the data in our tables, and the tables are in the database. So we can then start querying the database and start getting insights from our data. So that is the next action we are going to look into right now. So before we go, there's something I would like to show us. There's this thing we call database diagram. If you right click on it, click on new database diagram, it will bring this one in. Just click on yes, and then it will show you all the tables in your database. So the reason why we are doing this is to see how the tables are related or connected to each other. So sometimes it really helps us to understand how to build our query, to write effective and efficient query. So we select everything. So click on control and select all the tables and click on add. So once you click on add, it will populate them in this place. So we can close this once they are populated. So the next thing it will do is that it will connect this table together using the foreign key and the primary key. So looking at this now, you can see that the region table, the side with the key is where the primary key is, and the side with this infinity sign is where the foreign key is. You can see that the region table is connected to the sales table through this region ID, and also the sales table is connected to the account table through the sales rep ID, and the other table is connected to the account table. The account table is connected to the other table through the account ID, and the web event and the account table. The account table is connected to the web event using the account ID. So by understanding this would allow us to be able to write efficient query and be able to see how the data are connected to one another. So in the next videos, we'll start exploring our data and seeing how we can uncover insight and make data-driven decisions. So let's dive into writing some queries right now. So we'll start with the select statement. It is the core SQL command you'll use in every query. What the select statement does is that it allows us to retrieve data from a database table, and then it returns the data as a result table. So these tables are then referred to as result sets. So we can then export this table into maybe Excel or CSV file. So the syntax of select statement is we write select followed by the column name, and if we have more than 2 columns, we can then do comma, put the next column name, comma, and the next column name, and after that we put the from clause, which would then allow us to specify the table where we want to retrieve the column from. So select, we name the column, and then the from, we name the table we want to select from. So the other one is that if we would like to select all the columns in the table, we just use the asterisk sign, and then we do the from clause and the table name. So this is often read as select star from table name. Do you understand now? Select star from table name. So let's take an example. We would like to use the select statement to retrieve a single column from the others table. So we'll do select ID from others table, or we can say select, if we want multiple columns, we can say select ID followed by the other column account ID from the others table. So if we want to select all the columns in the others table, we will then say select star from others. So let's go to our SQL Server to test out this statement. So when you're in your SQL Server, always ensure that you have this backwoods paper DB selected here. That is where our table lives in. This is the database where our table lives in. So if you do not have this selected and you write your query and try to prompt the wrong database, then you will get a wrong result, or you might run into an error. So the first thing is that we would like to select the ID from the others table. So we write the select and the ID, we'll do ID, then press enter and say from. So once you do from others and put a semicolon, let's run this and see the result we have. So we can see all the IDs right now from the others table. So that is selecting a single column. So if we want to select multiple columns, so just before we go far, there's something I would like to show us. If we like to comment our code, which is a good practice when writing SQL code, we do 2- and then put the comments in front. So select 2 columns. So we'll do select. And one thing is that SQL Server have IntelliSense built into it that allows us to write query faster, so by giving us suggestions. So the way to activate this IntelliSense is that when you write select, don't put the query name first, then go to the next line and do from, and then write the table name. So we want from others. So once we come back to the top here and we do ID, comma, account ID. So let's do dbo.others here. dbo.others. Account ID. And we run this. So right now you have to select this, and let's put the semicolon in front. You have to select this, because if you click on execute directly, it will execute the first SQL code we have at the top and then this alongside it. So we don't want that, and it will result into having 2 tables, 2 results tables. So right now we just want to see these 2 columns. So let's do execute. So you can see the ID and the accounts ID. So let's say we want to see all the records in the others table. So to see all the records in the others table, all records in the others table. So we'll say select star. To get the star is doing Shift 8 from dbo.others, and then we'll run this. So we then get all the records and all the columns in the others table. So that is how to do the select statement. So you notice that I intentionally skip out the semicolon. So if you skip out the semicolon and right click and run the code, it will definitely run, but it is just a good practice to always have it at the end of your SQL code. And also SQL is not case sensitive. You can write the select and the from clause in lowercase and it will also run, but for the sake of readability, it is always good to ensure that you put the keywords or the SQL command in capital letter. So in this lesson, we've learned how to select a specific column from a table or all the records in a table. So this select from is the core SQL command we will use in all queries. See you in the next lesson. In this video, we'll be talking about the top clause. We use the top clause to retrieve a certain number of data rows from a database table. And this is especially useful when we're dealing with tables that contains millions of rows. By selecting only a subset of rows, you can avoid long waiting time and quickly gain insight into the data. So let's look at the syntax. So the syntax is that we use the select and follow it with the top clause immediately, and in the bracket we specify the number of rows we would like to return from our data and followed by the column names. And also, if we would like to select all the columns in our table, then we can use the select top number of rows star from the table name. So let's take an example. So if we would like to select the top 10 and specifying the column ID, so we can do select top 10 ID from others table. Or if we want to do multiple columns, or if we want to select all the columns. So usually it is used when we want to select all the columns, and we can easily use this to preview our data or return some subset of the data. So let's take an example. Let's go to our SQL server. Let's return the first 10 rows from the others tables. So we'll do select. We'll do select top, and in the bracket we do 10. So we want all the columns, so we do star from others. And once we run this, we should get the first 10 rows. See now that the result we have are the first 10 rows. So the top clause is always placed immediately after the select keyword. We then specify the number of rows we want, and then from the tables we would like to get the record from. Now that you know how to quickly preview your data with the top clause, you are ready to write more queries and dig deeper into your data set. So we'll see you in the next video. In the last video, we talked about the top clause, which allows us to specify the number of rows we want to return from querying a data set. So in this video, we'll be talking about the where clause. Right now, we know the select from statement, and from now on, as we write more advanced queries, we'll be adding more clauses to this select from statement. And now we want to look at the where clause. The where clause allows us to define a condition when retrieving the data from a table or combination of two tables. It returns a specific value from the table only if the specified condition is met. So the syntax is that we write the select from and then we put the where clause to follow it. So we select the column we want from the table, and then we'll specify the condition that needs to be met. So once the condition is met, the result is then returned to us. So let's take, for example, we get this email from the sales manager at Paxwood Paper. So the email says that, "Hi Mike, I'm meeting with one of our customers today. Would you please provide me all orders from these customers with account ID of 4251. So what the sales manager wants is to get all orders from this account ID. So we know that when we query the orders table, we only need to see the records that are for account ID of 4251. So let's go to our SQL table to write this out. Usually it's a good practice to do select star from orders table. So it's actually a good practice to first look at all the records we have in the orders table. So we have all these records and then we can see the account ID. So once we have this, then the where clause comes in. We then say where account ID equals, we then give the ID number, which is 4251, and then we do semicolon. So let's run this. So this is what the sales manager is asking us to get for him. So he wants to see all the orders this account has made, and once we have this, it is either we send this to the sales manager as an Excel file, or probably we can then build some visualization into this. So what has happened is that in the account ID, the filter is applied to each row, and then the rows that are returned are the ones that met the condition we have specified. That is, the account ID must be 4251. And we have to keep in mind that the where clause goes after the from clause, and this order of these clauses is crucial. If they are out of order, the query won't run properly. So as we build more complexes, we will often use the where clause to filter our data, and we can combine this with various comparison operators, and we'll look at them in the next video. In the last video, we saw how we can combine the where clause with the select statement. In this video, we are going to take the where clause to the next level by combining it with comparison operators. And these comparison operators allows us to define precise conditions for filtering. So this will allow us to ask more meaningful questions of our data. And the syntax or the symbols for the comparison operators are the greater than, less than, greater than or equal to, less than or equal to, not equal to. The not equal to sign can also be represented using the less than and greater than sign. So it's still the same thing by using the exclamation mark and equals to. So by having this understanding now, we can then, let's say for example, we have a request from the sales manager. So the request goes that, oh, I'm doing more investigation on our sales. Can you get me top 5 orders where the dollar amount of gloss paper is greater than or equals to 1,000? Also, I would like to see top 10 orders that have total dollar amount less than 500. So we have 2 questions from this manager. So let's go to our SQL server to answer the question. So to answer the question, the first question is to see the top 5 orders where the gloss amount in USD is greater than 1,000. So like I said, it is a very great practice to look into our data first before trying to answer the question. So let's see all the records we have on the orders table. And by looking at this, we can then look at what we have. So we can see that we have the standard quantity, we have the gloss quantity, the poster quantity, and we also have the standard amount. Those are the paper type, the amount of standard paper type sold, the gloss amount sold, the poster amount sold, all in USD, and the total amount sold for the 3 type of paper, all in USD. So what the manager wants to see is the top 5 orders where the gloss amount in USD is greater than 1,000. So the first thing we can do here is filter our data to see where the gloss amount is greater than 1,000 or greater than or equals to 1,000. So we'll do where the gloss amount USD, gloss amount USD greater than or equals to 1,000. So if we run this, so we can see all records where the gloss amount is greater than 1000. But if you look at the bottom right hand side, you will see that we still have 1579 rows, which is more than what the manager is requesting. So the manager would like to see the top 5. So we just put in the top 5 in clause in front of select top 5. And let's run this. So now we have the result for the top 5 orders where the gross amount is greater than or equals to 1000. So other paper type might be greater or less than 1000. We are less concerned about that. We have been able to filter to exactly what the manager is asking for. So the second question the manager is asking for is to see the top 10 orders where the total amount in USD is less than 500. So right now we want to see the total amount in USD less than 500. So we already know the method to write this query. So let's do select from orders, and we do where the total amount, which is the total amount in USD, is less than 500. So we want to get the top 10. So we'll do select top 10, and then we want to return all the columns. So we'll do that. So if we run this, so we can see our results now that all the orders we have here, none of them are greater than 500, and we can see exactly that there are 10 rows. If you look at the bottom right corner, we can see that there are 10 rows that have been returned. So that's to answer the manager, and this can always be sent maybe through Excel file or the convenient method the manager would like. So the comparison operators, they are not just for numerical column or data alone. We can also use them to filter down non-numerical values like text. So in particular, we use the equal and not equals to. So for example, we can say where customer name equals to United Technologies. And one important thing is that it has to be in quotation, single quotation. So we have to also pay attention if our values or data points are in double quotation, then we need to put that into factor. And more importantly, beside this equals to and not equals to comparison operators, we can also use operators like the like operator, the not like, and the in when working with text feed. But we would look into that in later lessons. Let's take a practice question. So the sales manager has come back to us and say, can we provide him with account details of Exxon Mobil company? So the manager would like to get their primary point of contact and also the website name. This now, we need to look into the accounts table to be able to give this information to the manager, and also we'll be using the where clause and specifying exactly the company name. So the hint is that from the account table, return the company name, the website, primary point of contact for the ExxonMobil. So pause this video and answer the question. Here's the solution to the practice question. So let's do select star from. Now we are to look into the accounts table. That's where we store the details of our customers. So accounts, if we run all this, so we can see that we have the ID, the name, the website, the longitude and latitude, the primary point of contact, and sales rep. So what the manager would like to see is just the name of the company and the website and also the primary point of contact. So we'll then write that we want to return name of the company, we want to return the website, and we want to return the primary point of contact. So from there, we would like to filter it down to ExxonMobil, where name of the company equals to ExxonMobil. So it will be in a single quotation. So let's run this. So we can see exactly the results the manager is looking for. So for ExxonMobil, the website is www.exxonmobil.com, and the primary point of contact is Song Shield. So the manager might want to pass an information to them, maybe to notify them of the late orders or something. Maybe there will be delay in the orders, or probably we would be making changes to the orders. In the last video, we have seen the where clause with the comparison operator. So in this video, we'll be looking at the where clause with the logical operators, and the logical operators allows us to filter data beyond just the simple equality test that we have been doing before. So the syntax or the keywords for the logical operators are these. So the first one we have is the like, which is used to find the pattern in text when you are not exactly sure of the value you are looking for. And we have the other one, which is the in. This lets us filter based on multiple specific value without writing multiple or condition. So we have another one called the not. So this is combined with the in or like keywords to exclude rows that match a certain condition. And we have the combination of and between. So we use these combined conditions where every criteria must be met. And with between, you can specify if the value falls within a specific range. So the or operator, this returns the row where at least one or multiple condition is true. So let's take a look at examples of this. So for example, let's say we have a table called the web traffic, and we have companies that have come through referral URL. So the digital marketing manager would like to see all companies or all records that have come through the Google domain. So if you look at this table, we can see that there are some companies that came through Google and some came through Facebook. And if we use the previous comparison operators that we have been using, which is just the equal to, if you look at the first query, so writing the select from web traffic where refer URL equals to Google would not give us any result, because in the refer URL, the text we have there is not exactly Google. So it is a combination. It is like a link which have some extra character at the end. So it is the second keyword that would actually work for this kind of questions. That is, we want to see all the records where the domain is Google. So right now, the query that would work for us is select from web traffic where referrer like. So we are using the like keyword now instead of using the comparison sign, which is a logical operator, instead of using the equal to operator. So what this like will do is that it would then look at the referrer table, which is actually a text data, and then pick out anything that's like Google. So let's use that word, anything that is like Google. So this actually work more for text data. So what this is now doing is that we have to put everything in quotation mark, and the first thing we need to understand is the first percentage sign and the last percentage sign, and in between we have to put the text we are trying to match in between the first and second percentage sign. What the first percentage sign is telling us is that we want any number of character before the Google, and what the second percentage sign is telling us is that if after the Google we also want any number of characters. So we can have any characters before the Google, we can have any number of characters after the Google. So if we use a single percentage sign, let's say at the back, like just at the starting point of the text, use a single percentage sign. Let's say we have percentage Google and then nothing in front of it, no other percentage sign. So what that is telling us is that we want any character before that Google and no extra character at the end again. So it will be any other thing attached to Google and nothing else must be attached to the front. If we switch the row and at the end of this we put only percentage sign at the end and there's no percentage sign at the start, so that means we want all text or character that starts with Google and then anything can then follow. So that is the way we use the like operator or the logical operator. So let's move on, and let's take an example with our database. So you receive this email from the sales manager that says, I need 3 separate lists of all companies whose names start with C, all companies whose name contains the strange 1 somewhere in the name, and all companies whose name end with S. So let's tackle these questions in our SQL Server. So what the account manager wants to see is all records, select, start from accounts, and if we execute this, you can see all this. But what the sales manager would like to see is all companies that start with letter C. So we then specify our condition into this, and to specify a condition we use the where clause, where we know what we are trying to look into, the name of the company. So name, like, we use a like, and this time around we first put our single quotation, so we have to do that. And the manager would like to see all companies where the company name starts with C, capital letter C. So we do capital letter C, and then anything can follow this, then a percentage sign. So once we do that, let's run this. So now we can see we have 37 rows. So we can see that all the names of the company that we will have in here must start with letter C. So you can see the results, that all the results we have here, all the name of the company starts with letter C. So that has answered the first question. We have the first list. So the second list the manager would like to see is to see all companies whose name contains this strange 1. So the second question, all company. So we select, we can just use this statement again. Let's copy this. So as you move along this, and with your confidence, you discover that you have to do more of copy and paste of code to make you work faster. So all companies whose name contains the strange 1. So this time around, we know that we want to have any character at the start of 1 and any character at the end. So we just put in double quotation at the start and quotation at the end, and put in 1. So let's run this. You can all see that we have these places now where we have 1, 1, 1, and that is the second list. So the third list is to get all companies whose name end with letter S. So let's paste this, and then we just note that we want to have any character at the start of S and no character at the end of S. So let's run this. So we can see all the companies here now. The names all end with S, S, S at the back. So that's the list the manager is requesting for. So let's continue with our explanation of the logical. So the other example we'll look into is the all on in example. So the manager has come back and said, okay, please get me all others from these account IDs. We have account ID 1001 and the account ID 1021. So the manager would like to get all others from these account IDs. So let's go back to our SQL Server to answer this. So select everything from accounts, where we want to specify the conditions now, the account ID. Sorry, we are meant to look into the orders table, where account ID we then specify the ID we've been given, which are the 1001 and the 1021. So you have to specify the list of what you're trying to check in comma. So let's run this. So if we look at this now, we'll discover that all the orders here, their account ID must only be 1001 or 1021. So if you look at this, we have 38 rows. So this same result, we can also get it using the OR operator. So let's copy this. And now we would say where account ID equals to 1001 or account ID equals 1021. So let's run this. You see we have the same results, which is 38 rows. So the only difference is that this is a bit more cleaner than what we have in OR. So that is why we say we use in to replace query where we need to write multiple OR, and it makes the code cleaner. So sometimes you might not always have it like this, but for this kind of questions, we can either write the first SQL code or the second SQL code. So let's move on. So the other example we have now is the example of and between. So the manager has come again and said, okay, this is a new year, which is January 2017. We are interested in identifying customers who made paper purchases a while ago, specifically those who bought between 3 and 9 months ago, that is between April and October 2016. So for this particular question now, there are two ways to tackle this question. So we can use the AND keyword and which is a logical operator, and the comparison operator, or we can use the between and logical operator. So let's go to our SQL Server and answer this. So first we look at the orders table, select star from orders, and let's run this. So we can see our orders right now, and we can see the occurred at date. So the condition is specifying that we should get the orders that occur between 1st of April and the 1st of October 2016. So we then do where the occurred at, we are specifying our condition right now. So the first one will be writing, the first query we'll be writing is using the comparison operator and the logical operator. So the comparison operator is that we want to ensure that the date is greater or equals to, because that is our starting date, 1st April, that is our starting date, which will be 2016 04 01. And then this is our logical operator. So we do another occurred at less than or equals to. So our dates must not be greater than the 1st of October, but it can be 1st of October. Do you understand now? Less than or equals to 2016 10 01. So let's run this. So we can see these are the orders that have occurred within 1st of April 2016 and 1st of October 2016. So this is using comparison operator and the logical operator. So we can have this same result using the between and. So let's write it. Let's copy this code. And in the condition right now, so we change it just to between 2016 and we delete this. So what this is telling us is that we want all orders that occur between April 2016 and October 2016. You can see this is a bit shorter and more cleaner than the one we have at the top. So it all depends on the one you understand better. So we can combine the comparison operator and the logical operator, or we can just use the logical operator directly. So let's run this. Before we run this, we see that we have 1823 rows. Let's see what we have now. then we have the same 1823 rows. So that is how to use the between and logical operator. So for the OR example, we have already seen OR in action some while ago, but right now we have another question from our manager, which is that we are looking for opportunity to sell new type of paper to our existing customers. We would like to identify orders where a customer omitted one type of paper. So they are trying to upsell customers. Some customers bought one particular type of paper and they omitted another type of paper. So for this company, Backwoods paper, they have 3 types of paper, like we have explained before. They have the standard, the gloss, and the poster type. So sometimes some customers will only buy maybe gloss and standard, and omit poster, or poster and gloss and omit standard, just the combination of all these. So they would like to see customers who have made orders and have omitted one of these papers. Do you understand? So this is where the OR logical operator comes in. So let's go back to our SQL Server to answer this question. So we'll select everything from orders table, and this time around the condition we are going to be specifying is where the standard QT is equals to 0, or where the gloss QT equals to 0, or poster QT equals to 0. So let's run this and see what we will have. So we can see now that we have some orders where the poster is 0, and we have some orders where the gloss is 0. So I think we also have some orders where everything is 0. So we have customers that have maybe probably canceled their order or something like that. So this might be the situation here when everything is 0. But we can also see that there are combinations where at least maybe 2 types of the papers are 0, or maybe one particular type is 0. Do you understand now? So that is what the manager would like to see. So we achieve this by using the OR logical operator. That is, one of these would actually be true, and in an event where, or in another where one of these is true, then return that record for us. So if you look at the first record, the poster quantity is 0. So that is where that situation is true. And if you look at another record, the gloss is 0. That is where the situation is true. If you look at another record, everything is true, so it will return them. And we have places where the standard order quantity is also 0. So that is the OR operator. So now that we have seen all the logical operators, these are practice questions that we'll go through. You can pause this video and answer the questions before you look at the solution to these questions. So the first question is that the manager has come and said, "Hi Mike, I need the account name, the primary point of contact, the sales rep ID for Walmart, the target, and Nordstrom." The hint for this is that we'll look into the account table and return the company name, the primary point of contact, sales rep, that are for Walmart, Target, and Nordstrom. So those are the companies we are trying to look into. We are trying to get the primary contact of this company, the sales rep ID, and the company name. We have the company name already. So the second question is that I need all the information regarding individuals who were contacted via the channel of organic or ad words. So this is coming from the marketing manager. So the hint is that we look at the web event table and return all columns where the channel is organic or ad word. The third question is that I would like to see the account name, primary point of contact, sales rep ID, except for Walmart, Target, and Nordstrom. So this one, we have seen this in the first question. So the manager has come back again and said, okay, get me all other company details except for the Walmart, Target, and Nordstrom. So we are going to check into the account table and then use any of the logical operators that we think would match this. So the practice question again for the question 4 is that the manager would like to see all orders where the standard quantity is over 1000, postal quantity is 0, and gloss quantity is 0. So this right now, if you look at the int that has been given here, we'll check the orders table, return all the columns where the standard quantity is greater than 1000, the postal quantity is 0, and the gloss quantity is also 0. So this place we are using the AND logical operator. So the next one is that the manager has come and said, okay, we are looking for opportunity to sell new type of papers to our existing customer. We would like to identify orders where a customer omitted one type of paper, would like to narrow to only recent orders, those placed after October 1. So we have tackled something like this before, but now we have been told that they would like to see the orders that are placed after the 1st of October. So the int is to use the order table where standard quantity is 0, postal quantity is 0, or gloss quantity is 0, and the occurred at is greater than 2016 October 01. So this question will be using the OR and logical operators. So the other one is that the next question is we need to get all orders where the standard quantity is 0 and either the gloss quantity or the postal quantity is over 1000. So this is also going to take, if you look at the int, this is also going to make use of OR and logical operators. And for this is the last question now, and this now, the manager would like to see all company names that start with C or W, and the primary point of contact contains ANA or ANA, the capital letter ANA, but does not contain EANA. So this one is to use the account table, return or column, use the logical operator of OR and logical operators. So pause this video and answer the questions, and in the next video you get the solution. So this is the solution to the practice question, and we'll tackle that one after the other. So the first one is we need to get the account name, the primary point of contact, and the sales rep ID for Walmart, Target, and Nordstrom. So we are going to use the account table. So let's do this. So first select all from the accounts table, and let's see what we have there. So we have the name, we have the website, and the primary point of contact, and the sales rep. So what the manager would like to see is the name. So let's put that in our select statement, and the primary point of contact, and also the sales rep ID. So once we have that, then the condition is that they have to be for Walmart, Target, and Nordstrom. So we say where name. So this time around you are going to use the in logical operator. So we say where name in, and then we'll give the names we are trying to target. So we supply this and ensure that all the names are in quotation. So we supply Walmart, and after that we supply Target, and after that we supply Nordstrom, and then put our semicolon at the end. So this is missing. So if you look at it now, we did not do and. All the names have to be separated using comma. So even if you are putting in 10 names, they have to be separated using comma. So let's run this. So we have this right now. We have Walmart, the primary point of contact is Tamara, and this is the sales rep ID that is responsible for Walmart. So we have that for target and not strong. So that is for question number 1. So for question 2, the manager would like to see all information regarding individuals who were contacted via the channel of organic or AdWords. So this time around, we are going to do that in the web events table. Select all record from web event. So we specify a condition where the channel. So sometimes let's see what we have in web event before we do that, because it's actually a good idea to preview your table before you start specifying the where condition. So you know that where channel in, we are going to use in now because we have been given to the channel to check, which is organic, and the AdWords. So let's run this and see what we have. So all these results now will contain channels of organic and AdWords, so nothing else will be included in this. So that is for question number 2. So let's try and answer question number 3. Question number 3, we have this message that I would like to see the account name, primary point of contact, sales rep. So that is looking at question number 1, but we want all the records that are not in Walmart, Target, and not strong. So what we'll do is let's copy this. We're just going to modify this query and do not in. So let's run this, and everything we will be getting now must not contain Walmart, Target, and not strong. So we can see that we have something different right now. So that's for question number 3. So let's move to question number 4. So for question number 4, the manager would like to see all orders where the standard quantity is over 1,000, the poster quantity is 0, and the gloss quantity is 0. So this right now, we are going to use the orders table. So let's select all from orders table. If we run this, let's see our table first. So we can see standard quantity, gloss quantity, poster quantity. So we then need to specify our condition right now. So the condition is that where standard quantity is over 1,000, standard quantity is greater than 1,000, and poster is equals to 0, and gloss is equals to 0. So the difference between and or is that for all the conditions you are trying to check, one of them has to be true, and once a particular condition is true, then it will return record for that. But for and, all the conditions have to be true. If one of the conditions is false, then there won't be any record to be returned. So what we are looking at now is that we need a record where the standard quantity is greater than 1,000, the poster quantity is 0, and gloss quantity is 0. So if there are no record matching this condition we have stated, then we won't get any return. So let's run this. So we can see that out of the orders we have, it is only 2 records that are matching this condition. And if you see the standard quantity, in the first record, the standard quantity is greater than 1000 and the rest of the paper type are 0. And for the second record, the standard quantity is greater than 1000 and the rest of the paper quantity is 0. So all the conditions are met, and it's only 2 rows that have met these conditions. That is why we are having 2 rows. So it's important to understand how to use the AND logical operator and the OR logical operator. So let's move to the next question. The next question is, we are looking for opportunity to sell new types of paper to our existing customers. We would like to identify orders where a customer omits one type of paper, and we would like to narrow this only recent orders. So to only recent orders alone, those placed after 1st of October. So to do this, so question number 5, to do this, we have already done something like this before. So we know that in this type of situation, so is either one of the paper is 0. So we are using OR, and then we then use the AND logical operator to combine it with the date condition. So let's start with the select star from the orders table, and the condition is where the standard quantity is 0 is equals to 0, or the gloss quantity is equals to 0, or the poster quantity is equals to 0. So, and would also want orders that occurred after 1st of October 2016. So we'll say and occurred at greater than the date 2016 10/01. So I would like you to pay attention to this right now, because when reading this using English, this query is actually correct, but if we run it, we would not be getting the right answer. Let's run this. You see we have 1900 rows, and it might not be returning the right answer because we don't know whether the AND is trying to make sure whether the poster quantity and the occur date are the same thing, if you understand right now, or what is actually happening. So for us to be sure, if you look at this record number 8, you can see the occurred at date is 2015, but we are trying to look at orders that have occurred in October 2016, after October 2016, but we have orders that have occurred in March 2015. So looking at this now, we already know that our result is actually wrong, and this is coming from the fact that we did not really enclose. We have to enclose our query into brackets to be able to specify the order we would like the query to run. So what I mean by the order we would like the query to run is that first thing we like to do is we would like to see is that we want to see all orders where either standard quantity is 0 or poster or gloss is 0. Do you understand now? After that, we then filter down again and look at all orders that have occurred in 2016 October. So for us to be able to do that, we then place a bracket, open bracket here and close bracket here. So by doing this, we are telling our query to first take care of this, run all this, and after that, once all these are true, when all these are done, then look for all orders that occurred after this date. So the result is that this must be true, or everything we enclose in the bracket, and this must be true, what is after the and a record or result must be returned for that. So let's run this. So now you see that we have a different result set now. So we can look at the occurred at date, and you see that the orders we have right now, they all occurred after 1st of October 2016. And we then either have maybe one of the three type of paper, one of them is missing. And if you look at this record again, you may be thinking, why do we have 1st of October here if we said we want something greater than 1st of October? So the reason why we have that is that it is also considering the time. To understand that it is also considering the time, and the time we only consider is to 12 midnight, and everything after 12 midnight of 1st of October is already after 1st of October. Do you understand now? So that's for question number 5. So let's do the last two questions now. Question number 6 is, we are trying to get all the orders where the standard quantity is 0 and either gloss or poster quantity is over 1000. So this is straightforward. So we just use the same logic we have explained initially, which is we are selecting everything from the orders table. So this time around, our condition is standard quantity has to be 0 equals 0, and either the gloss or poster quantity is over 1000. So we'll then say, and that gloss quantity greater than 1000, or poster quantity is greater than 1000. So like I said before, we need to specify this condition now. So this condition are two different conditions. This or condition now, they are two different things. So we are looking for where standard quantity is 0 and gloss quantity or poster quantity. So either of these can be true. We can have places where gloss quantity is greater than 1000 and it will be less in poster, but the standard quantity will always be 0. So let's run this. So you can see the result right now that the standard quantity stays at 0. Do you understand now? So we then look into the other condition, which is this gloss greater than 1000 or poster greater than 1000. So if you look at the condition for the other one, you see that in the first record we have gloss is greater than 1000 but poster is less than. Do you understand now? And if in the second record you see that gloss is less than 1000 but poster is greater than 1000. So either of the two conditions must be first met in that bracket, and then it has to look for where standard quantity is 0. So that is for number 6. And for the last one, which is question number 7. So what we would like to see is all companies name that start with C or W and the primary contact contains ANA, ANA, or capital letter ANA but does not contain ENA. So to do that, we are going to be looking into the accounts table. So select, for this we are going to say select all from the accounts table, and let's run this first. So we have this. So where we are going to specify our condition is on the name column. So we say where name. So the first condition is saying find all company names that start with a C or W. So where name, like the quotation mark. So since we are looking for all company names that start with C or W, so we do C percentage or W, which is now W percentage, and primary point of contact. So we'll do, and so the next condition will be on primary point of contact column, primary point of contact, contains Anna or Anna, like small letter A and capital letter A. So like, so sorry, this should be named like this. And primary point of contact like ANA. If it is contained, so we start with percentage ANA, percentage, and this, or, so let's copy this again, primary point of contact like this, and this should be capital letter. So again, we have but does not contain ENA, so we'll do and primary point of contact, not like this EANA. So right now, the next thing we have to do now is to then put the bracket to specify how the condition needs to be done. So the first one is that this name like this or like this is just a single condition. So we put open, we close and open the bracket here. And sorry, it should be at this point here. And primary point of contact also, it's a single condition like this or like this. So we then say bracket here and bracket here. And since this is a single condition, there's no point of putting it in bracket. So, and another thing is that we can then break this down to another line, and also we can break this down to another line. Do you understand now? So let's then put our semicolon. So if you understand what we have done now, this is a single condition. Name has to be this or this. Primary point of contact has to be this or this, and primary point of contact must not contain this. So let's run this. So you can see that we have two records. So you can see that all the names start with C, and if you look at the primary point of contact, you can see Annabelle and Chanel, and also nothing like this E. So if you run this query up to this point, you'll see a different result. Let's run it up to this point. So let's run it for this point. So you can see we have two different reports because we can see all the names are contained. You see all the names contain Wells Fargo, and if you check the primary point of contact, there's nothing like, some of them does not have ANA, so that's one of the criteria we need to look into. So that's the answer to all the questions we have. So if you have any question or not, something is not clear to you, you can put your question in the comment section. The next video will be looking at other by clause. So the other by clause will allow us to sort our record based on a particular column. So see you there. In this video, we'll be talking about the order by clause, and this clause allows us to arrange or sort the record in the result set. So the syntax of this is that we do select from, and the where clause can be optional. So that means we can write select statement and omit the where clause and then followed by the order by clause. The order by will take the name of the column you are trying to sort the result with, and then in front of it, it should either be ascending or descending. So it is optional if you specify the ascending or descending. If the ascending or descending is not specified, the column will be sorted by default in the ascending format. But if you specify, then it's sorted by what you have specified. And also we can sort by more than two columns. So we can do order by column 1, and then we give whether we want to sort by ascending or descending. Column 2, whether we want to sort by ascending or descending. Our column can be a time column of data type of column, or number, or text. So if our column is a time column or of a data type of time, and we do ascending as the way we would like to sort the order, so it will sort our time from the earliest to the latest. So if we do descending, then it will sort it from the latest to earliest. So it's like the opposite of it. Same thing with number. If you do ascending, it will sort from lowest to highest, and if you do descending, it will sort from highest to lowest. And for text, if you do ascending, it will sort from A to Z, and if you do descending, it will sort from Z to A. So let's take an example. So we've got this email, and it says that please get me the top 10 most recent order we have got. So to do this, let's go to our SQL Server and answer this. So we would like to get the top 10 most recent orders. So let's select everything from orders table. If we run this, we'll get all the orders we have in our database, and what we would like is the top 10. So let's do top 10 clause, and from here now we don't have a condition to specify, so we just like to sort our results. So we want to sort our result by the most recent order, which is the latest order we have. So we'll go to the next line and say order by. We want to order by the date column. So the column that contains the date or time is going to be the occurred at. And then we need to specify whether we are sorting by ascending or descending. So since we want the latest order, we need to sort this by descending, so that will give us the latest order. So we do DESC, and then we'll run this. So this is our top 10 most recent order, and this can then be sent to the manager. In this video, we'll talk about arithmetic, and arithmetic can be used to derive columns containing simple or advanced calculation. So derived columns is creating new column that is a combination of existing column, and it is also known as calculated or computed column. A name or alias is given to this derived column using the as keyword, which we would see in an example very soon. Mathematical expression can be used to derive new column, and these mathematical operators are used. The first one is multiplication, the addition, subtraction, and division. So SQL orders of operation follow the same arithmetic rules, which is on PEMDAS, same as the standard math. So let's take an example. We get this email from the sales manager that says, please get me the top 10 most recent orders we have got for standard paper. I would like to see the order ID, the amount in USD, and the percentage of standard paper in the order sales. To do this, let's go to our SQL Server to answer this question. So we know we have to look into the orders table. So let's do select star from orders table. So let's run this first. So we have this, and we would like to see the top 10 recent orders. So let's say we have to order by the occurred at. And since we want the recent order, we do DESC. So let's run this. So we have the recent orders at the top, and from there we would like to get the top 10. So now we have the top 10 orders. So what the managers would like to see is the account ID, the standard paper quantity, the standard paper amount in USD, the total amount for all order, And we would like to see what percentage of standard paper is the revenue. So let's start putting that in order. We want the account ID, the standard paper, the quantity, the standard paper amount. After that, we'd like to see the total amount. And also, the manager would like to see the percentage of standard paper revenue. So to do that, we know we are going to use the amount we generated from standard paper divided by the total revenue, which is the total amount in USD, or multiply by 100. So let's do this. Let's open bracket and do standard paper amount divided by total amount, or multiply by 100. So let's run this. So we can see now that we have all this information, and if you see the last column, it has no column name. So the reason why this is giving us no column name is because it is a derived or a calculated column. So it doesn't get stored into the database or into our table. So it's just a temporary column. So for us to be able to distinguish this, we need to now give it a name. So that is where we come in using alias. So we'll now say as, then we give the name we would like to use. So we say standard revenue, PCT, and if we then rerun this, you see now the column now has the name we have specified, which is the standard revenue PTC. So that is how to use the right column, and it is all coming from the arithmetic operation we have performed using the mathematical operators like the division and the star. So that is arithmetic operation in SQL. So there's also what we call aggregation, which we'll be looking at in future lessons. Thank you. We have come to the end of the basics of SQL, and here is just a quick recap on the SQL concept and commands we have covered so far. So the core SQL command, the first one is the select, and it is used to specify the column you want to retrieve. And after that, we have the from. We call all these keywords or the clause. So we have the from keywords, which is also used to indicate the table where the column exists. And after that, we have the top keywords, which is used to restrict the number of rows returned by your query. We have the order by clause, which allows us to sort the result set by a specified column, and we can do this by having the ascending or descending order. We have the where clause, which allows us to filter results based on conditions that we have specified. And also we have the like keyword, which allows us to filter rows when the column contains a specific pattern. So the in keywords allows us to select rows with a column value matching any of the specified value. And we have the not keyword, which allows us to invert the condition or negate a particular condition. So we often use this with like and in. And also we have the and keyword, which requires that all specified condition must be true. The all keywords requires at least one of the conditions to be true, and the between keyword is just a simple way to filter within a range. So all these together form the SQL concept and the core command of SQL. So in the upcoming lessons, you will learn about joins, which is a powerful feature that allows you to combine data from multiple tables. All the commands and operators we have covered so far will continue to be essential as you start writing queries that draw on data spread across different tables. So you've made a great progress by learning to write your first SQL code. Now you are ready to dive into even more advanced topics. So let's get ready to unlock even more deeper insight from our data.